This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be seeing about the problems on center of gravity of simple and composite bodies. The course outcome of this topic would be identify the centroid and center of gravity for the simple and composite plane sections from the first principles. And the topic covered would be problems on center of gravity of simple and composite bodies. The topic learning outcome would be understand the concept of centroid and center of gravity involved in practical engineering problems. So the problem that is given is a solid hemisphere of 20 millimeter radius supports a solid cone of same base and height 60 millimeter as shown in figure. Locate the center of gravity of composite section. So this is a three-dimensional object having two sections or two bodies. One is this hemisphere and other is a cone. Okay, this is the base. So the radius or the diameter of this hemisphere and the diameter of this cone's base is same, and that is given as 20 millimeter radius, nothing but it is 40 millimeters. The diameter would be 40 millimeters, and the height of the cone is given as 60 millimeters. Height of the cone is given as 60 millimeters. So this is the data given, and we need to identify the center of gravity of this particular solid. So now let us find the solution for this given problem. The body is symmetrical about axis YY. That is, first we have considered the axis which is given here, that is YY. So the axis of symmetry is passing through the center of the solid. So we can consider that central axis as the reference axis for our problem, and its center of gravity lie on this axis, right? As this is the axis of symmetry, the center of gravity will lie on this axis. So coming to the first section or first solid as hemisphere, what we have done, we have divided this given object into two. As given in the question, we have divided this given object into solid cone and hemisphere, right? So first we are considering, or else we can take solid hemisphere and the solid cone. So first we are considering the hemisphere here. So the volume of this hemisphere is given as 2 by 3 pi r cube. So when we substitute the value of r as 20 mm, we can obtain the value as 2 by 3 pi into 20 cube, that is equal to 16755.16 millimeter cube. This is the volume of the hemisphere. Then the value of y1, which is the distance of the centroid or center of gravity from the axis, x-axis, that is base axis which we have considered. You can observe here, the axis which we are considering are passing from the base, x-axis is passing from the base, and y-axis, that is given as the axis of symmetry. So the distance of this center of gravity from the base is obtained as total length is 20, total radius of the hemisphere is given as 20 minus 7.5. That 7.5 is obtained as 3r by 8 here. You can see, because we have got the formula for the center of gravity of the hemisphere from the axis shown here. Okay, the axis from this diameter of the hemisphere or base of the hemisphere we do have. So we can get the distance of this center of gravity from the x-axis or the axis which we have considered as total distance, that is 20 minus this distance. That distance is obtained with the formula 3r by 8. So 20 minus 7.5. This is the formula used for obtaining, or this is the procedure how to obtain the center of gravity of the hemisphere. Now when we consider the cone, the solid cone, the second solid, we can get the volume of the cone as V2, that is equal to pi r square by 3 into h. When we substitute the values of this radius and simplify the equation, we will be obtaining pi into 20 square into 60 by 3. So from this we can get the value as 25132.74 millimeter cube. So that is the volume of the cone. And coming to the distance of the center of gravity of the solid cone from the base axis, that is x. Base axis, that is OX, that can be obtained as, we do have the formula of the center of gravity distance from the base of the cone, that is h by 4. So that h by 4 is obtained as 15. Okay, and it is the center of gravity's distance should be considered from the reference axis. So we need to add this 20 also. 20 plus h by 4, that is 15. So complete it would be 35. So in this way we have obtained the center of gravity of solid cone, individual solid cone with respect to the reference axis. So now the position of the center of gravity from the OX, that is base OX, can be obtained as y bar, that is equal to V1 y1 plus V2 y2 by V1 plus V2, where V are the volumes and y are the distances of the center of gravity from the reference axis. So when we substitute the values, those would be 16755.16 into 12.5 plus 25132.74 into 35 by 16755.16 plus 25132.74. When further simplification is done, we will obtain the value of y bar as 26 millimeters. So this is the distance of the center of gravity of the complete composite solid, complete compound solid from the reference OX axis. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.